think you guys want a custom object detection video with Tensorflow.JS. Let's do it. What's happening, guys? My name's Nicholas Renault, and in today's video, we're going to be building our very own real-time sign language detector using Tensorflow.JS and React. Let's take a deeper look as to what we're going to be going through. Now, in this video, we're going to be covering a bunch of stuff. So we're going to go from end to end, from exporting our pre-trained TensorFlow model to integrating it into a full-blown React.JS app. So the first thing that we're going to do is convert our pre-trained TensorFlow model into a TF.JS friendly format. Then what we're going to do is take that same model and host it on cloud object storage. So this is going to allow us to work with it inside of our application. We're then going to leverage a pre-written computer vision template that I've used in a previous video. So this is going to make your life a whole heap easier when building it up. We'll then use that app to make real-time detections using React.JS and our webcam. And then last but not least, you're actually going to be able to visualize these real-time detections on the screen. So you'll actually be able to see all the different sign language models that we've actually got pre-trained. Now, the cool thing about this video is that this could be easily applied to a whole heap of other different use cases. So say, for example, you wanted to build a stop sign detection algorithm, or say, for example, you wanted to build something that's more along the lines of microscope detection. You can use this exact same app and these same steps to convert your model and deploy them all the way through to a front-end app. Enough on that, let's take a deeper look as to how this is all going to work together. Alrighty, so there's 6 key steps that we need to go through in order to get this up and running. So first up, what we're going to do is take our pre-trained TensorFlow model and convert it to a TF.JS Graph Model. So we'll be able to take the model that we pre-trained in our sign language detection video and use that. And I'll also include the model details for that. So if you want to just download that, you don't have to go and walk through that entire video yourself. We're then going to host that on the cloud object source. I'll show you how to set all of that up. We need to make sure that CORS is set so that we can access it through our app. So this basically means that our app can go out to other web pages and pull down our model. We're then going to build it up in React.JS and build our standalone front-end application. Step 5, we'll use our webcam to detect images and make object detections in real time. And we're going to wrap it all up together inside of our React.JS app. And again, we're going to be using Tensorflow.JS. Ready to do it? Let's get to it. Alrighty, so without further ado, let's jump right into this. So in terms of what we've actually got to get through, there's 8 key steps that we need to walk through. And we're going to be tracking to this markdown document. Thanks for the subscriber that gave this suggestion. So we're actually going to be going through each one of these steps, and as we get them done, we're marking them off. So just quickly, we first up need to export and convert our pre-existing Python model, and I'm going to make this entire repository available through a GitHub link. Just check the description below, as well as the completed code will be available there. So the core thing that we're going to be taking a look at are these pre-trained checkpoints. So these pre-trained checkpoints effectively represent our pre-trained model and are going to allow us to perform our real-time sign language detection. So once we've exported that and converted it to a TF.JS friendly format, then it's pretty straightforward from there. So we've just got to export this and host it on cloud object storage. So this is going to give us a place to host our model. Then what we're going to do is we're going to clone down a computer vision template. So this is going to allow us to get a kickstart in building our app. We're going to install and update some dependencies, load our graph model from our URL. So from this particular step here, we'll then make some detections. So we'll clean up our computer vision template code to work with our new model. We'll then create a drawing function and a label map. So we'll be able to actually map our detected functions to our pre-trained labels. And then what we're going to do is we're going to draw it to the canvas. So we're going to specifically use a function called request animation frame to give us a nice smooth transition for that. All right, so let's get started. So the first thing that we need to do is export and convert our Python model. Now within the repository, or within the baseline repository that I'm going to link below, you're going to have a bunch of stuff, but specifically you're going to have all the pre-trained models that you need to kick this off. So it doesn't need to be GPU intensive. You're going to be able to leverage all the stuff that we've done before. Specifically, what we're going to be taking a look at is everything under this models folder. So if you take a look inside of the folder, let's just open it up. So specifically, we're going to be working inside of this custom object detection folder, and we can just make it a little bit bigger. So if we look inside of there, we've got a bunch of files. So we've got label image, models, scripts, and workspace. Again, we'll make this a bit bigger. So if we click on workspace and models, and my SSD mobnet. So there's a bunch of stuff in here, but specifically you can see all these checkpoint files. So these checkpoint files are the files that we're going to need in order to host our model. But what we really need to do is convert this into a Tensorflow.JS friendly format. So we're just going to create a folder and we're going to name it converted. And inside of that folder, we're going to be exporting to there. So basically everything that we're building from there, we're going to be exporting to there. So there's a pre-existing export folder and 2 pre-existing converted folders. So if you wanted to leverage the ones that we've done before, you can. If you want to do it from scratch and take a look, and specifically if you're working with different models, you'll do it from scratch. But we're going to do it now anyway, so you can see what it looks like. All right, so inside of this particular folder, so my SSD mobnet, we're going to create 2 new folders, one called converted and one called export. So first up, we're going to freeze our inference graph and export it to here. And then what we're going to do is we're going to convert that to a Tensorflow.JS friendly format, and we'll save it in our converted folder. So we can close that now. What we're going to do is jump into a Jupyter notebook, and inside the repository, you're already going to have a notebook called tutorial. So we're going to be working with that. So let's jump into that now. So again, this is our custom object detection folder. We're going to open up our tutorial, and you can see there's all the code here that allows us to train our model from scratch. So if you wanted to do this for a completely different use case, not sign language detection, you could definitely do that. So say, for example, you wanted to detect different street signs, or if you wanted to detect issues or, like, for example, skin cancer lesions, you could definitely use this code there to go and run through that. In this case, we've just got 2 last steps that we need to go through in order to get our model up and running. So we need to save our graph and convert it. So let's go on ahead and start doing that. So it's a bit of a long command, but we're going to take it step by step and walk through it. Now, before we go on ahead and export our model, we're just going to make sure that we run our path script or cell. So this is going to contain all of our paths, so we can easily pass it through to our final command. And we also need to run this one here, which says custom model name. Now what we can do is actually start writing our Python script. So let's do it. And we'll just make this a bit bigger. And let's start writing our export script. Alrighty, so that is our Python script to save our graph done. So let's walk through what we've actually written there. So we're actually going to take this command and run it from within our directory. But before we get to that, let's actually walk through it. So, all right, so what we're going to be doing is first up, we're going to be using our exporter main v2 script. So this comes from the Object Detection API library. So what we're going to be doing is first traversing to there, so TensorFlow models, research object detection exporter main v2.py, and then we're passing through a bunch of options. So we're specifying our input type. In this case, it's going to be an image tensor. We're then specifying our pipeline config path. So this is in TensorFlow, workspace, models, my SSD mobnet, and pipeline.config. I'll actually show you where these are. Hold up. If we just drag this over to here and make that look like that. So if we go into custom object detection, so what we're actually doing first up is we are going into TensorFlow, models, and then we're going into research, and then object detection. And then from here, you can see that we've got a bunch of export scripts. The one that we're going to be using is exporter main v2. So this one down here. So that's what this first line is doing. Then what we're doing is we're specifying the image tensor. That's fine, all kosher. Then what we're doing is we're specifying where our pipeline config path is. So if you watch the sign language detection video from start to finish, you'll see how we actually build our pipeline config. I'll include a link somewhere above that you can take a look for that. Alrighty, so pipeline config. So if we take a look, this is going to be stored in TensorFlow, workspace, models, my SSD mobnet, pipeline.config. So if we go to TensorFlow, workspace, models, my SSD mobnet, you can see that we've in fact got a pipeline.config file there. And then what we're also doing is specifying where our train checkpoint directory is. So TensorFlow, workspace, models, my SSD mobnet, and these are all of our checkpoint files here. Again, this is going to be available in the repo that you can download and work with. Then we're specifying our output directory, so TensorFlow workspace models my SSD mobnet /export. So it's going to export into this folder. Now what we need to do is run this. So we're just going to put this all onto one line just so it's a little bit cleaner, and then we can paste it into a command prompt or a terminal if you're on a Mac, and we should be good to go. Let's make this full screen again. Alrighty, so we can copy this, and then if we open up a command prompt, I'm just going to navigate to our folder, and we are in custom object detection. And if we take a look, you can see that we've got all of our folders in there. So what we can do is now run this Python script, and we should have an exported model. So let's go on ahead and do it. Looks like we didn't include, so we just need to make sure we've got a space in between each of these, otherwise we're going to get some errors. Let's just check that again. All right, let's rerun that. So that error is basically saying that we didn't pass through an output directory, but we did, we just didn't have a space, so it didn't detect it. So let's try that again. All right, that's looking successful now. So you can see that it's running and it's now going to export. So we'll be right back as soon as that's done. Perfect, so that looks like it's done. So let's go and check it out. So if we go into our export folder, you can see that we've exported our models successfully. So you can see we've got our checkpoints here. We've also got our saved model, and we've got our new pipeline.config. Now, the next thing that we need to do is convert this into a Tensorflow.JS model. So the first thing that we need to do is actually install the Tensorflow.JS Python libraries. So this is a converter library, or a library that's going to help us get our model from Python script to JavaScript. So let's go on ahead and install that. So really all we need to do is run the pip install Tensorflow.js command. All right, so that's really the command there. So we just need to type in !pip install Tensorflow.js and run that. Perfect, so I've already got it installed, so it was pretty quick, but if you're going from scratch, it might take a little bit longer. But really, once you've got that installed, then you can begin writing the command to convert this to a TF.js model. So let's start writing that command, then we'll break it down. Alrighty, so there's quite a fair bit that we've just written. So let's take a step back and take a look at what we've written. So the first command that we're going to be running is Tensorflow.js converter. So this comes pre-packaged with Tensorflow.js, and it's going to help us export our model. Then what we've got are a bunch of input flags. So specifically the first one is the input format, and in this case we're passing through TF saved model, because when we exported it, we actually created a saved model format. And if you take a look inside of your models and exported folder, you can see that we do indeed have our saved model.pb or protobuf file. So this is going to allow us to convert our model. Then we're specifying a bunch of output node names. Now this may change or differ depending on the type of model that you've trained. In this case, these are the ones that we're going to be using. So specifically, we're going to be capturing our detection boxes, detection classes, detection features, detection multi-class scores, detection scores, number of detections, raw detection boxes, and raw detection scores. Again, this is all going to be available in the repo, so if you didn't catch it, by all means, do check that out. Then we've specified our output format. So in this case, we're going to be passing through a TF.JS graph model, because when we go and use Tensorflow.js later on, we're going to be loading our graph model using the load graph model method. Then we're passing through our signature name. So when we train our object detection models using the Object Detection API, you're going to get a signature name, and by default, or more often than not, it's going to be serving default. Then what we're doing is we're specifying two file paths. So the first one is where our saved model actually is. So in this case, it's going to be taking a look at TensorFlow workspace models, my SSD mobnet export and saved model. That's exactly what we're looking at here. And then we're specifying where we want it to go. So again, it's going to be TensorFlow workspace models, my SSD mobnet converted. So in this case, that's going to be this folder here. So that's that blank folder that we created right at the start. Again, what we're going to do is put this all onto one line and then execute it. So let's go on ahead and do that. And again, remember, you just need to make sure that you have a space between each one of these flags. And then we can copy this. And again, we're just going to go back to our command prompt and then run this. Sweet. So that's our model effectively exported. So if we go into our export folder, or our converted folder, sorry, you can see that we've now got our model successfully converted. So we've got our model, and then we've got a bunch of these shard bin files. So our model, this is going to be the most important thing. So if we actually open this up, you can see it's a bunch of JSON that represents our trained model. Now what we're going to do, let's just quickly check our to-do list. So we have now successfully completed this one. So we can now mark that off as done. Alrighty, now the next thing that we need to do is just go on ahead and host our model inside of Cloud Object Storage. So the reason that we do this is that so our app can globally access our model. So let's go on ahead and do this. So in order to host our model, what we're going to be doing is using Cloud Object Storage inside of IBM Cloud. Now, if you don't have an instance created, you just need to go to cloud.ibm.com/object storage/create. So if you just select the light tier, it's all free, more than enough to actually get this started, and then hit create. So this will create a new Cloud Object Storage instance. Then what we're going to do is create a bucket. So let's go on ahead and do that. So I'm just going to jump into my existing Cloud Object Storage instance and create a bucket to hold our assets. So what we now need to do is just hit create bucket over here. So if you take a look, you can see it's just there. So let's go on ahead and create a bucket. And what we're going to do is just hit quickly get started. So this is going to allow us to quickly set up a bucket. So if we go and select next, and we're just going to name it Tensorflow.JS real-time model. So you can name it whatever you want. Just make sure you follow the naming rules and then hit next. So once we've named our bucket, we just need to upload our files. So in this case, we're going to drag all of our model files that we need. So our bin files as well as our model JSON, and we're just going to drag it into here. And we're just going to let that upload. So as soon as that's finished uploading, we're going to set our bucket to public, and then we're going to use the IBM Cloud CLI to make sure that we've got CORS enabled. So CORS basically allows us to access our files from our application. Booyah! So we've got upload success and our files have been successfully uploaded. What we can then do is just hit next, and we can see all of our bucket details. We can then go into bucket configuration. And from here, if we select access policies, what we want to do is make sure that we've got public access. So this is going to allow us to work with our bucket from within our app. So in terms of this, all we need to do is just hit public access from up here. So if we hit access policies, public access, and then hit create access policy and enable, this is fine. Don't worry about the warnings. So in this case, we actually need public access in order to work with it from our application. So that's all good. Now, as I said, the next thing that we need to do is just make sure that we've got CORS enabled for our bucket. So CORS stands for Cross-Origin Resource, sharing or scripting. So this makes sure that our app can work with this particular bucket. Now, in order to do that, what we first need to do is make sure that we have the IBM Cloud CLI installed. So if you're doing this for the first time, just make sure you select the right installer. So in this case, if we're working on Mac, select the Mac one. Windows 1, select the Windows 1, Windows 32, so on and so forth. So if you just click that and run through the installation, pretty straightforward. Then what you need to do is you need to install the Cloud Object Storage plugin. So it's just this command here. So let's go and take a look at how to do that. So I'm going to log into IBM Cloud through using the CLI first. So to do that, we can just type in IBM Cloud login. And this is just going to require your regular IBM Cloud login details. And then just select an account. So I've just selected my account. And then what we're going to do is install this plugin. So I've already got it installed, but if we need to install it again, we're just going to copy this command and paste it into our command prompt. And in this case, it's asking us, do we want to reinstall it or not? I don't need to reinstall it. Let's just hit no. So once that's done, so once you've finished installing the Cloud Object Storage CLI or the plugin, You just need to make sure you target the right region. Now, in order to determine the right region, if you just go back to your buckets, and in this case, we're going to type in the name of our bucket, and it's going to search for the one that we need. And I believe it was this one that we're using here. So Tensorflow.JS real-time model. So you can see that the location is in AU SID. So we're going to target that region. So let's go on ahead and write that command. Cool, so we've now targeted that region. Now what we need to do is just pass through some configuration in order to enable cores. Now, in order to do that, we just need to write a little bit of JSON. So I've pre-written it, so we can take a look. So if you take a look at what we need to write, it's basically one big JSON string. And again, I'll make this available in the GitHub repo so you can grab this. Relatively simple. So it's basically stating that we're passing through cores rules, and we're saying that we're allowing all headers, allowing all methods, or in this case, sorry, we're allowing the get method because we're going to be getting our model, and then we're allowing all origins. So this just makes sure that our app can connect to that model that we've set up. So we're going to paste this inside of our D drive or inside of our model folder. So let's go and grab it. So this is our cores config. I'll make this available in the GitHub repo as well. And we're just going to paste it in here. Then what we're going to do is we're going to run a command to send this config to our bucket. So let's go on ahead and write that command. Okay, so before we run that, let's just quickly take a look at what we've written. So basically, again, we're using the IBM Cloud CLI. We're accessing the Cloud Object Storage Service, and we're running the command bucket cores put. So this is going to pass through those cores credentials that we've just set up, or those cores rules. Then we're specifying the bucket that we want to send it to. So in this case, we're specifying Tensorflow.JS real-time model, which is the name of our bucket, remember from up here. And then we're stating what type of configuration that we're sending through. So -- cores configuration, and we're passing a file, and that file is called coresconfig.json, which is this file here. And keep in mind, we're inside of the same folder that our file is in right now. So if it wasn't in the same folder, then we'd need to pass through the full path. So let's go ahead and run that, and hopefully we should have our cores set. Perfect, so we've got a successful message. So it says okay, and we've successfully set cores configuration on this particular model. All right, so that's our hosting done. So if we go back to our to-do list, we've now done this. Now onto the good bit. So we've taken our Python model, we've converted it, we've exported it, we've hosted it. Now we can start building our JS model. So the first thing that we're going to do is we're going to clone our real-time computer vision template from GitHub, and then we're going to install our dependencies. So let's go on ahead and start doing that. So in order to clone, we're going to stay inside of our custom object detection app folder, and we're just going to grab the link that we need. So in this case, the link that we're going to need is just github.com/knickknack/React computer vision template. So I set up this template following a couple of the computer vision videos that we did. So basically this gives you a bit of a shell to be able to build some real-time computer vision apps with React. So we're going to grab this, and we're going to go back to our command line and just type in git clone and then our link. And then if we hit enter, this should create a new folder inside of our custom object detection app folder, which includes our template. So let's run that. Reasonably easy step. Then what we're going to do is just open it up inside of VS Code. So we're actually going to CD into our template and then open it up. Perfect. So now what we've got is all of our template code. So if you actually take a look inside of the source folder, there's a bunch of stuff already pre-written. Let's make that a little bit smaller. So we've already got a bunch of to-dos that we can actually go and step through. We're actually going to walk through this and build it up. If we go and check our to-do list again, we've now done that. And what we now need to do is install and update our dependencies. So by default, when we clone our template, we're not going to have our modules or our libraries or our dependencies installed, so we've got to do that ourselves. So in order to do that, we're just going to go into our package.json file, and this is going to contain all of the dependencies that we need for our particular application. Now, it does include some other legacy ones that we used for our real-time object detection tutorial, so we're going to rip a few out. So specifically, we don't need that one anymore. which is Tensorflow-models/Coco SSD. So we can remove that. And we're just going to make sure that we've got an upgraded version of Tensorflow.js. So at Tensorflow/TFJS, we're just going to make sure that we have 2.7. And we can also remove finger pose. We're not going to need that as well. So you can remove that line and hit save. Then what we can do to install these is just create a new or open up a new terminal. And then to install all of the packages that we've got in here, we just need to type in npm install. And this will take a couple of minutes, but once you've got that installed, you'll have all of your dependencies ready and good to go. Alrighty, so those are our dependencies now installed. So you can see our node modules folder is now appearing there, and we've got all the stuff that we need now installed. Now let's go on ahead and quickly update our to-do list. So we've now gone and installed and updated our dependencies. So we can mark that as done as well. So let's jump back into our application and start making our updates. So the first thing that we need to do is we can actually skip this. We don't need to import a pre-built model because we're going to be loading from our graph model that we hosted. So what we're going to do is skip to do as well. Or skip to do number 2. So we're going to do that in a second. So we'll actually come back and do our drawing at the end. The first thing that we need to do is actually load our network. Now we're going to be loading this from our hosted model. So what we need is we need our link to our hosted model first up. So let's go to our bucket and step into that. And the link that we need is actually the link to the model.json file. So let's wait for that to refresh. So the way to get the link is just we're going to select our model.json file. So these 3 little dots over here, hit object details, and then we just need this object public URL. So if we copy that, go back to our model, we're going to paste that in here temporarily and actually write our code to actually load it up from there. So let's go on ahead and load it up first, and then we'll take a look at our code. Okay, so we've got our link and we're just going to paste it into here. So what we've written is we've created a new variable called net. So this represents our neural network, and we're going to make it asynchronous. So we're going to wait for it to load, and then using the Tensorflow.js library that we loaded up here. So this was part of the pre-built template. We're going to use the load graph model method to load our model from that link that we just created. So remember, this is from our bucket and this is where it's currently hosted. Perfect, so that's now done. So if we take a look at our to-do list, we've now loaded our graph model from our URL. Now the next thing that we want to do is actually start making our detections and clean up the rest of our code. So let's actually start writing our detection code. What we're going to do is we're also going to change this number here. So we're going to set that to 16.7. So this basically specifies how frequently we're going to make detections using our webcam. So 16.7 seems to be the appropriate number depending on your monitor's refresh rate, but it's going to give us a smooth detection. Alrighty, so what we want to do now is scroll on down to here and start making our detection. So we can delete this line and start writing our code to make detection. So let's go on ahead and do that. Okay, so that's our first bit of code that we're going to write. So the first thing that we're doing, so there's a couple of steps that we're actually going through here. So we've got these 5 new objects that we've just gone and written. So the first one uses tf.browser.fromPixels, and to that we're passing through our video. So our video is actually being drawn from our React webcam component. So this is pre-configured, but if you want to see how all of this has been set up, the facial landmark detection video that we created a while back is a great example of that. So this is basically going to get a video feed from our webcam. Then what we're going to do is convert that to a number of pixels using the tf.browser.fromPixels method, and we're going to store it in a variable called image. The next thing that we're going to do is we're going to resize this image. So we're going to use the tf.image.resizeByLinear method, and then we're going to pass through our image and reshape it to 640 by 480. So this is the size of our webcam feed that we're getting. And then what we're going to do is we're going to cast it into an integer 32. So this is just going to make our model perform a little bit better because that's what it's expecting. Then we're going to expand dim. So this is just going to put it in another set of arrays. This is how our model expects the feed to come through. And we're going to store that result inside of a variable called expanded. Then this is where the magic happens. So using our network that we're passing through to this function. So remember, we set up our network up here. Then we're calling this function that we're actually writing in. So that function is called detect. We're passing through our network. So using our network, we're going to use the method execute async, and then we're going to pass through this pre-processed image. Ideally, if all things holding equal, we should get some detections inside of our object variable. So this is going to allow us to have new detections from our model. But before we actually run this, what we actually want to do is make sure that we manage our memory. So Tensorflow.js can be a really memory-hungry application. So what we want to do is make sure that we delete and get rid of any existing tensors. So this is going to make sure that we keep our memory as tight and as up-to-date as possible. So to do that, we can use the Tensorflow.dispose method. So what we really want to do is we want to dispose of image, resize, casted, expanded, and object in preparation for our next detection. So we're going to do that just under our draw something method down here. So we're eventually going to draw our results to our screen here, but we want to make sure that once we've drawn it, we get rid of anything that's remaining. So let's go on ahead and dispose of those. Cool, that's good. So, and then what we're also going to do is we're going to console log out our object. So at the moment, we're not actually going to see any results rendered to the screen, but we ideally want to make sure that we're going down the right track. So if we console log out this object, we should be able to see all of the results from our detections at least. So let's save that and start up our app. So in order to start up our app, what we're going to do is just run the npm start command. So if we type in npm start, this will start up our React app. And ideally, it should open up a new browser. And if you go to localhost 3000, if it doesn't open automatically, you should be able to access your app there. So let's just wait for this to compile, and then we'll be able to see some of our results. Perfect. So you can see that our webcam's on our screen. You can see the green screen behind me. If we just go on and inspect, so we'll actually take this down once we're starting to draw properly. If we go to our console, ideally in a second, what we should start seeing is some detections. And there you go. So we can now start seeing some of our detections. So from here, we've got a whole heap of tensors. Now, each one of these represents a separate thing. So if you actually open these up, you're going to be able to see each of the different detections. Now, the ones that we're most interested in are number 1, which represents our different boxes. So this represents a set of coordinates, so x, y, width, and height. We also want number 2, which represents our classes. So this represents what's actually been detected. So is it thank you? Is it yes? Is it no? Is it hello? Is it I love you? So those are going to be the different sign language models that we've actually got available here. And then the last one that we're going to want is scores. So this represents how confident it is that what's been detected is actually accurate. Now, right now, again, this isn't all that pretty to look at. We've just got a bunch of tensors being console logged out. What we actually want to see is we actually want to see some stuff drawn to the screen. So let's go back, update our app, and then we'll take a look at what this looks like once we're drawing to the screen. And while we're at it, we can update our to-do list. So in this case, what we've done is we've now started making detections. We just need to complete step 7 and 8, and then we're all done. So let's jump into our app. And then what we really need to do, we can stop our app right now. So what we really need to do is finish up this drawing step here and actually bring in our drawing here. Now, in order to write our drawing script, we're going to create a new file and we're going to call it utilities.js. And then the first thing that we need to do is we need to define our label map. And then we're going to define a drawing function. So our label map basically is a dictionary that represents all of the different sign language poses that we're likely to encounter from our model. So the 5 different ones that we're going to have are hello, I love you, thank you, yes, and no. So let's go on ahead and define our label map. Now, as well as defining those labels, we're also going to define different color properties. So this is going to allow us to have some nicer formatting when we actually draw to the screen. So let's define it and then we'll take a look. Awesome. So what we've now gone and done is we've defined our label map. So in this case, whenever we get our detections, what we're actually going to get from our text is just a number. So we're going to get 1, 2, 3, 4, or 5. Now, we don't actually want to just display the number to the screen. We want to display the actual label. So when we actually go and display the label, we're going to convert our number to this particular name here. So if it's 1, we're going to print out hello. If it's 2, we're going to print thank you. 3, I love you. 4, yes. 5, no. And now we've also specified some colors. So when we actually go and draw to the screen, we're going to be using these colors. So let's go on ahead and now define our drawing function. So our drawing function is just going to be called drawRect, and to that we're going to pass a number of parameters. So specifically, we're going to pass our boxes, we're going to pass our classes, our scores, the threshold. So we're also going to specify a threshold, so after which we don't actually draw to the screen. We're also going to pass through our image width, image height, and our canvas. So let's start defining this. Okay, so this is our initial drawing template. Now we haven't actually done any drawing here, but I wanted to take a step back and explain what we're actually going to be doing. So as I said, we're going to be defining a function called drawRect. So this is going to be our rectangle drawing function. And to that, we're going to be passing those 3 different arrays that I mentioned that we're going to need. So our boxes, our classes, our scores, our threshold, our image width, our image height, and our canvas. Then what we're going to be doing is looping through each one of the detections inside of our boxes array. So for that, we're going to be using a for loop, and we're going to loop through each one of those. We've then got a condition which checks if we've got boxes, if we've got classes, and whether or not our score surpasses the threshold. So this basically ensures that we've got valid detections. Now let's wrap this up and actually do our drawing. Alrighty, so that's our drawing function done. So we've gone and written 8 additional lines of code. So let's take a step back and work through these. So the first 4 are setting styling. So in this case, we're setting our stroke style, and this is going to be the color of our boxes. So in this case, we're going to be setting it to the color of the detected label. So in this case, whether or not it's 1, 2, 3, 4, or 5, and we're going to be grabbing the color. So this allows us to grab these colors here. So red, yellow, lime, blue, or purple. So say for example, our object detection model comes back and has detected class 2. Well, then that class actually represents thank you. So the box is going to be drawn as yellow. Then we're setting the line width. So this is basically how thick the line around the square is. In this case, we're setting that to 10. We're setting the color of our text to white, and we're also setting our font to 30 pixels in Arial. All of this you can play around with. If you have a preference for how you want it to look, you can change it. By all means, go for it. Then what we're doing is we're actually drawing. So we're going to begin our path, and then the first thing that we're going to do is put down our text. So here what we're doing is we're grabbing our detected number, so that's going to be a number, and we're passing that through to our label map and grabbing our name. So say our model comes back with number 2, then what we're going to be doing is passing label map 2, and we're going to be able to grab this name which says thank you. Then what we're doing is we're appending to that our score. So this basically allows us to see how confident we are that that's an appropriate detection. We're then scaling it, so we're basically multiplying it by 100 and dividing it by 100 and putting it inside of math.round function. So this is basically going to round it down. So rather than having a huge confidence number, we're going to have it to 2 decimal places. And then what we're doing is we're placing it at the X and Y coordinate. Now, because we're scaling our image, we need to multiply it by the image width and the image height. And then we're also bumping it up a little bit just to make sure it's above our box. Then we're drawing our rectangle using the rect method. So up here, I should mention that we use the fill text method to put down the text. Here we're using the rect method to draw a rectangle. And then we're passing through our starting point, so X and Y. And again, we're scaling those. And then we're passing through our width and height. And again, we're scaling those. And we're also dividing it because remember the model that we trained was based on a 320 by 320 mobile net. But when we're actually getting our image, we're actually passing through an image which is 640 by 480. So if you divide 640 by 320, that gives you 2. And if you divide 480 by 320, that gives you 1.5. These are our scaling factors here. So you can see 2 and you can see 1.5. Now what we need to do is actually bring in this drawing function into our main application. So up until now, we're not actually doing anything with it. So we need to import drawRect. So if we go back into our app.js file, so up here, if we just use our standard import functions, let's bring it in. All right, so that's our function imported. Let's just quickly check our to-do list because I think we've just marked off another thing. Yep, we have. So we've created our drawing function and our label map, so we can now mark that as done. One more thing, we're almost there. So if we go back, now all we need to do is go down to step 5, so it should be around line 5960, and then we're actually going to draw with it. So let's go on ahead and do that. So we're going to wrap this entire function call inside of a request animation frame method. So this is basically going to give us much smoother detections when it comes to actually displaying to the screen. So let's write it up. And that's actually our code done. So now what we're going to do is actually test this out. So I'm just going to open up my blind so we get a little bit more light in here, and then we'll see it live and in action. Alrighty, now what we need to do is just start up our app. Hopefully we don't have any errors, and let's take a look at how we go. So again, we can start up our app using npm start. Oh, actually, let's take a quick look at what we actually wrote to run our function. So again, we use request animation frame, and then to that we pass through an anonymous function, and that function is actually running our drawRect method. So our drawRect method here, we're passing through our boxes, and specifically we're grabbing through the first detection, because remember we're passing through one frame at a time. And then what we're doing is we're also passing through our classes, our scores, and this is our threshold. So you can play around with this if you want a more or less accurate set of detections. Then we're also passing through our video width, our video height, and our canvas. So let's go on ahead and start it up and take a look. Oh, so it looks like we've got a couple. Oh, we haven't actually defined boxes and classes and stuff in here. So we just need to make sure that we actually define where our boxes, classes, and scores are coming from. So let's quickly do that. Save that, see if it doesn't look like we've got any errors now. Let's open our app back up. All right, so we've got our app running, and it looks like we're successfully drawing stuff to the screen. So you can see even on the green screen, we're performing pretty well. Looks like our line width is a little bit small, so we can play around with that. But you can see that we're successfully drawing to the screen. So if we take a look, so we've got hello, I love you, thank you, yes, and no. And there you go. So we've now successfully gone and built our real-time object detection app. So this is quite huge, right? So we've taken a Python model, we've converted it, we've hosted it, and we've now built a real-time app with it. So if we take down the green screen and test it out a little bit more, so we've got hello, I love you, thank you, yes, and no. Now, it doesn't look like our line width is taken, so let's quickly just check that. That's because this line width should be capital. Let's save it again. Jump back to our app. That's looking way better now. There you go. So that's our real-time app. So again, we're detecting hello successfully. I love you, thank you, yes, and no. And we can also do dual detection as well. So say, for example, we had 2 hellos or 2 I love yous. I love yous probably a little bit better. Let's get in front of the mic or camera. So there you go. So we've got 2 I love yous, 2 hellos, 2 yeses, 2 no's. Pretty cool, right? So there you go. So we've gone and built our entire object detection model that allows us to make real-time detections. Now, this can be applied to a whole bunch of different use cases. So if you wanted to do street sign detection, or if you wanted to do something completely different, you could use this exact same process to build your real-time detection app. And you can see it's still pretty quick. And the advantage of using that request animation frame is that you can see that it follows our hand and different objects pretty nicely. So it's got a much nicer animation than sometimes when you get jittery apps. Alrighty, so let's quickly check our to-do list. I think we've actually finished it up. So if we take a look, we're now drawing to the canvas using request animation frame, and we can now hit save. So again, if we take a look, let's just make sure we've successfully done that. So again, we're getting hello, I love you, thank you, yes, and no. So we've now wrapped it all up. So we've gone through those 8 steps. So we exported and converted our Python model. And again, this is all going to be in this side of the GitHub repo that you can pick up. We've hosted our model inside of Cloud Object Store. We've cloned our template. We've installed our dependencies, and we've loaded our graph model from our URL. Remember, we grabbed it from here. Then what we did is we made our detections and cleaned up our code. We wrote our drawing function. And then last but not least, we drew to the canvas. And that about wraps it up. Thanks so much for tuning in, guys. Hopefully you found this video useful. If you did, be sure to give it a thumbs up, hit subscribe, and tick that bell so you get notified of when I release new videos. And let me know how you went about building your app, and if you're building anything custom. Thanks again for tuning in. Peace.